The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to another D-Link webinar. Today we're going to be talking about the building blocks of a network. So basically going through building a network completely from scratch with some real life examples of a growing company. Before we get started, I do have a couple of workmen outside my house, so you might hear a little bit of noise. I will do my best to mute myself, obviously just to introduce Craig as well, who's with me as always.
Yes, hello everyone.
Craig's
back
got
again.
Craig's got a lot of talking to do today because we've got a lot of network diagrams, which Craig has been very busy building over the last week or two.
Yeah.
Okay. So as I said, basically we're here to talk about the building blocks of a network. So we've done in previous webinars where we talked about small to medium-sized businesses, about the deep dive, about all of the stuff that you need to do before making your first purchase. So wired or wireless, gigabit or 10 gig, do you want to be hosted by the cloud? So there's a number of things to consider as you go through. So what we're going to do today is we're going to take an example of a company that starts very small and gradually gets bigger and bigger over time. And as the company grows, their network needs grow with them. So we're going to go through the choices that they make in order to move on. So as you can see on the screen here, this is Andrew. Andrew spotted a niche in the market along with his business partner Charlie. So Andrew started to make websites for cats back in a few years ago. The growth of cat. He foresaw the YouTube trend of cat videos, and then he was well ahead of that. So he started up his web-based company in his shed. Very humble beginnings. But one of the major factors in Andrew's success was that he started. He looked at his IT network. He looked at what he had. He looked at where he wanted to be, and at every stage of the growth of his company, he planned out. He looked for a flexible and scalable solution so his network could grow and respond wherever it needed to be. Unlike Homer, who just realize that they have the internet on computers now. So Andrew and there's Andrew and Charlie working away in the garden shed there. So Charlie's Andrew's coder, and she's the brains behind there. So she's currently jamming on her iPod, really crunching some code, while Andrew is desperately trying to put together some deals for the business. So if we start to have a look at their basic network, I'll hand over to Craig, who'll talk through the finer details on this part.
Yes. So what we're going to do is we're going to try and evaluate devices and topologies as it goes from beginning to end. So as normal, let's get Andrew on the screen. So this is Andrew. He's our representation of Andrew. He's going to be our boss. And obviously Andrew is going to start off very simple with a PC, and that's where he starts maybe thinking about a domain, and he's setting up a website, and that's going to be the beginning of his network. Now obviously Andrew needs an internet connection, and Andrew needs a router for that internet connection. So let's say, for example, perhaps it's an ISP given router. So maybe it's not a business line, maybe it's just a consumer at this point. Now if Andrew's really serious, maybe this is the point where he can start thinking about getting the business line, at least temporarily, going to this this back of his shed where he's set up his network. And a business line will basically give you a static IP. And when you have that kind of thing, you kind of want a router that's going to power your network as well. So we'll have a think about what that router could be. But at the moment, let's just call that a gateway. So as the company grows, he's got Charlie there, which is his business partner, and she does all the coding and keeps things running while he does all the deals. Eventually, Andrew decides that he's going to bring some more people on. So we've got Barry and Darren that comes along and joins the crew. So at the moment, we're still running perhaps with our consumer router and things like that, but they all need an internet connection. So I'm going to draw a couple of lines there, and you can see that we've got 4 ports that are going to a router device, because generally, if you look at an ISP router, they're going to have 4 different ports available to them.
Yeah.
Now, as things start to get better, maybe they've got a bit of online storage and things like that. They pull in and push in different devices. Maybe they're storing it locally on their PCs and things like that, okay? Eventually, it comes to the point where they start to do really well and they need more manpower. So along comes Edward. So it's getting a little bit cramped in the shed, but it's still okay. It's a very large shed. Now, Edward needs an internet connection as well. However, we've run out of ports on the network. So now we have to start thinking about growing our network to provide things that are going to be installed as we grow the company. So the next step, let's have a look at the router and what we can actually use. So here at D-Link, we've got these, I suppose you would say prosumer, maybe business, maybe a little bit of consumer, somewhere in between there.
Yeah, definitely in between, isn't it, Craig? It's usable both as a failover for a business solution, a standalone for a small business, or just a person at home. Maybe they live in an area where the fixed line broadband isn't so great. So
yeah, absolutely. So it's really good for that small office, home office environment. So this is going to provide still 4 ports, but what it's actually going to also deliver is 4G LTE. And what that means is that you can have your internet connection coming in from your ISP, but you can also have a failover system, which is 4G. Now, I say failover, it doesn't have to be failover 4G. That could be your primary connection, and then you can actually use your normal ISP as your failover as well. So it's up to you how you do it and what kind of better connection you're going to get. But ultimately, having that integral part, because if the internet goes down, or if there's any problems with the speed, everybody trying to jam things up at the same time, you're going to need that little bit of extra grunt power to keep your business running. So this is the kind of thing that you would put. Also, if you are someone that's a home worker and you put one of these behind your network, you're securing all of your business devices as well, just in case the kids are doing things and that sort of thing as well. So there's different benefits to it.
Yeah, keeping the network separate from his home broadband was the reason Andrew went for the 4G model, I think, knowing Andrew personally as I do.
Absolutely. Yeah. So unmanaged switches, we're going to need some unmanaged switches in this scenario because we've run out of ports. We want to grow our network. We want other devices going to come in, be plugged in. But what an unmanaged switch is basically it's a plug and play device. You plug it into your router, you plug all the devices into the switch, you can plug switches into switches, and you start growing your network. It's all dummy, so it's all broadcast only. So imagine it as just growing that one single network. There's no way of managing the devices or anything like that, so you can't provide certain speeds and things to other people. You can't do a kind of prioritization. But an unmanaged switch at this point would probably be the right thing for Andrew and co. Now, smart switches is also something he can think about. At this point, it's definitely going to be on the agenda, but probably in this current stage, not needed. Now, smart switch, what that will do is it'll give you manageability. And smart switches can come not just 1 gig solutions, but also 10 gig as well. They can be PoE, PoE plus, and they can have lots of different alternatives like stacking, which we'll go into. We're definitely going to be looking at smart switches in the future, as we run through the slides, but right now that's not what we're going for. However, we do need to be aware that this is a possibility. Now, some companies, if you are really concerned, you can get 8-port managed devices. Say, for example, if you've got phones and things like that, you can start breaking them off. You can do quality of service so that if you are jamming up that internet connection, maybe you could think about smart switch in this scenario.
Yeah, I think if they were a heavily sales-driven outfit, that might have been the way forward for them, Craig, so that they could put priority on the Voip phone system to make sure that's the highest priority. But I think because they were more of a number crunching company, when they had 6 employees, they're not really that busy on the phones. It's mainly the PCs and devices, isn't it? So so that's why they stuck with unmanaged at this point. So
yeah, and then finally, unmanaged switches. You will definitely need managed switches as you grow as a company. we're going to have a look at those. Now, a managed switch gives you more control over the switching systems itself. In a big network, it probably have a little bit more switching capacity. There's definitely probably more features depending on whether it's layer 2 or layer 3 devices. And then you've got other fiber connections. It's just basically a bit more control that you're able to lend and a bit more grunt power. If you are doing sort of authentication with Windows servers and things like that, which is quite possible even in a small company, you might have a Windows server where you start doing things like that because basically you're setting up your internet connection for inbound traffic and providing services for people. So it's quite possible that you would also look at managed solutions. But let's go back now to our diagram and think how we can start plugging our things in. So now we're going to introduce a switch into our network. And what that switch means is that we can plug that device straight into the gateway. So no longer do we have to plug devices directly into the gateway. We can plug things into the switch now as well. So now everyone, including Edward, has a connection.
Right.
So all of the PCs are now up and running. Yay, there we go. So this might be okay for a few months, depending on the business. I'm sure it's going to be a very good business that Andrew's growing, so it's going to grow very quickly in our diagram. So we've mentioned that we've got internet traffic. It's constantly going out, this internet traffic. They're all fighting for each other, but the internet broadband speeds are not changing. They're a constant. So unless you get more lines, you probably want to offload as much information as you can locally and keep that kind of storage there so you don't have to keep going online all the time. So maybe hosting your own server is probably a good idea. Obviously, that server will need a connection going into the switch as well. So we're starting to grow our network more. Now, we have to introduce VoIP phones. So these are specifically going to be VoIP phones. Every VoIP phone still needs to be powered. Now, when you buy a VoIP phone and you don't have a PoE switch, you have to find a power supply to it. If you're happy to do that, fine, no problem. They can go into a data switch. However, you still have to plug them into a data switch anyway, right? So if you can alleviate some of that PSU problems that you might be getting where everybody's plugging in and you've got these PSUs all going all over the floor and people plugging into it, and you're running out of slots and things like that, running out of power, you might want to look at a PoE device. So if we was to plug that data connection in right now for that phone, we still have the problem of plugging in the other phones, okay? Because we've run out of data ports on the switch. So maybe we say this is an 8-port switch and it's a small unmanaged switch, and we've run out of ports. If it was 24 ports, you'd be fine. You'd be able to keep plugging things in. However, what we can start integrating is different kinds of switches for different suitability and what we want to do looking forward. So obviously, yes, we've got some phones that we want to plug in, but maybe we want to plug in some Wi-Fi devices as well. And now if you have access points and things like that, then maybe what you can do is get that PoE powered as well. Totally up to you. So power over Ethernet. What is power over Ethernet? It's exactly as it says. It's a Ron says right on the tin. So access points, they generally have about 15.4 watts is a maximum for your standard 802.3 AF. What it'll actually draw is probably about 10 watts. However, it's completely dependent on the type of access point you use. So if you're using a really high-powered access point, one that's got a really big broadcast, 4x4 aerials, Wave 2, all that sort of thing, you're going to need more power going through that switch. More power to drive the device. So you'll be looking at the next standard, which would be 802.3 AT, and that's up to 30 watts. And generally, it's going to be around, I'd say, a maximum of around 22, 23 watts. Depends on the access point, depends on the brand you go with. But you want to keep it to that kind of standard so that you know that the switch and the device that you're buying all incorporates to the standards. Now, once you've done that, you have to think about how much as a limit is going to be on that device as well. So for example, we've got VoIP phones going in, we've got APs going in. Maybe in the future we'll also want some cameras too. So you have to think about that, where you want to grow your company, what needs to be included. Now, a standard 24-port switch that we sell will probably have about 193 watts of power available to it. Now, if you keep putting access points, cameras, all that sort of thing, you have to budget yourself within that device. So just bear that in mind when you're making your buying decisions as well. So back to the diagram. Let's go. So we've got our switch, which is our data switch. That's still got its connection going to our gateway. All of our devices are still plugging into that data switch. We introduce our server. We've got phones that we want to plug into now. So what can we do? We can introduce a second switch, and that second switch will connect to our first switch. And you can see where we're going with this. We're going to start plugging the phones into that switch. Now, if we have a PoE switch, we don't need to worry about plugging these phones in separately. It just runs through the Ethernet cable, powers the phones. Everything is controlled by the switch. Now, at this point, we're still on this very flat network. So it's all flat, it's all unmanaged, everything's plugging in, but we're able to build this network. Everybody's got connectivity at this point, and we've got a decent, perhaps, gateway that we can have failover, and that's going to be good for a little while, I would say.
Yeah, and it's good. It's good planning, isn't it, Craig? Because keeping the one switch just to go to the PCs, that's an unmanaged, that doesn't need PoE. So he's made use of his switch there, and then he's thought to himself, well, we need a new switch, but rather than replace the old switch with a bigger version, he's just bought a separate PoE switch to power those phones. So
absolutely. So now he can think about, with PoE requirements, can go on the PoE switch, and anything else, like, for example, printers and things like that, they can go on the connect to the first switch. Yeah, absolutely. So we've got our extra ports, and we can even a few spaces on the router still if we want to plug directly into the router. So that's our very small working from your shared office environment. Now, lucky Andrew, he's doing really well in his business, as well as his business partner Charlie.
Those cat videos.
Yeah, those cat videos. Everyone loves those cat videos in lockdown, right? So, as we grow, he knows that he can't do everything himself. He's one person. He needs to sort of outsource this information. So all the customer calls, getting those customer calls, and maybe getting a receptionist to start taking those calls as well. And just providing him maybe like a personalized help for himself to run the business. He's going to need a sales account. He's going to need someone to go out there and get these sales. He's got to try and work with people. He can't do it alone. He's going to have to get and invest in a sales accountant. He's going to need more server space because he's running out. And then finally, he's going to need to hire more people to drive his business. So, bearing all this in mind, let's go get ourselves an office.
Got a plan.
So yeah.
Got to pack up those plants, yeah.
Got to pack up those plants, yeah, absolutely. So at some point, as your business grows, you probably want to move out of your mother's basement and go and get yourself an office. So let's transition that. So what would you do? Where would you look from a network perspective going in? So this is our inventory. This is what we're moving. This are all the people. So you can see the receptionist has her own PC in line. The sales accountant is going to have his own laptop because he's traveling around, he's meeting people. So we're going to have to account for all of these extra devices on our network. So how can we grow it? So we start with our internet. Now, this is where things might change from the get-go. So you're moving into an office, you know you want to grow your office, you're going to need a device that might be future-proof. Now, when I say future-proof, you want to think about segmentation. We're going to go into it in a little bit. But segmentation basically means you can start dividing up your network into certain chunks, so certain groups of people can talk to other certain groups of people. We'll go into that in a moment. Yeah. More importantly, it means that we've got other functions as well. So we can start assigning different IP addresses out to people. We can start doing quality of service on the gateway. We can start doing multiple LAN connections coming in. So at D-Link, we have a thing called DSR routers. And so it's DSR 1000s, things like that. And what that would do is that's a business grade gateway into your network. What it means is if you think about a leased line or anything like that coming in, or multiple lines, it's going to be able to fully accommodate for those additional devices, plus have a USB stick inserted into it that maybe you would have like a USB mobile device for that 4G LTE gateway. We need to upgrade our switches, I think, at this point. Now, you notice I've put 24-port switch. I haven't mentioned anything about models or whether it's managed or unmanaged. We're going to have a little chat about that. Let's have an evaluation. So what's next? What's going to be plugging into that switch? We're going to have all of our staff PCs. We want room to grow. I mean, if we just put in 8 ports and then have 8 PCs, what's that going to accomplish? It's not really going to accomplish anything for future growth. So 24-port switch will give us that extra port power for everything else as well. It's still non-PoE at this point. We don't need PoE at this time plugging into this device because all of our other traffic is going to plug into it too. So if you imagine you're sending something to a server and you're collecting that information and getting it back to the PC. Everybody's doing that. All 8 of those PCs are going to one of those servers and then pulling information back. So there's going to be a lot of connections. So you might want to think about how fast that connection speed is. So maybe gigabit ports, you might want to make sure everything's all gigabit rather than fast Ethernet. You want to make sure that the servers have got information that's going to be able to pass to those devices. So what you can do with some of these servers is you're able to install multiple NIC cards. And what you can do is you can do this thing called teaming, right? So maybe with 2 NIC cards, you can team them up and bond them. So maybe it's a 2 gigabit connection going to that switch. That way you've got 8 PCs sharing a 2 gigabit connection. So that throughput is a little bit more. Basically means that you're not throttling yourself. You're not fighting against each other for that bandwidth.
That's cool.
Now we've still got our extra PoE switch, right? This time it's 24 ports because we want to grow, we want more phones. Also, we're going to introduce some other concepts as well. So we've got 2 switches there, one plugged into the other. That's a really good point for us to talk about core, distribution, and edge. Alan, I think you've been through this with me quite a few times in the past. You're probably more of an expert at this point than I am.
I'm almost at a stage where I can explain it myself, Craig.
Good stuff. Okay, so core, distribution, and edge. I think some of you probably would have been very familiar with these terms. Maybe not so much the distribution part, but you definitely would have heard of core and edge.
Especially
What's a core?
What training course? Yeah.
Yeah, absolutely. Yeah. So core is going to be the grunt of our network. It's going to oversee everything else. Basically, it might be our gateway in and out as well. But more importantly, it's going to be the driving force of our network, which means it has to be powerful enough to cope with all of our network needs.
Yeah.
Normally what will happen is we have other devices that are plugging into this distribution level. Now, distribution device might be still powerful, but not anywhere near as powerful as the core, but it needs to drive everything underneath it. And that's where that edge comes in. So you can see them start building switches. So if we have all the same switches on the edge, and then we have a distribution that's the same kind of switch as our edge, that means it's going to be doing itself, plus any switches and any traffic that's plugged into those switches going through it and trying to push that to the core. So it has to have, the distribution layer has to have more grunt power than the edge, and the core has to have more grunt power than the distribution. That's basically how it works. But what it means is we can break it down even further. We plug all of our edge devices onto our edge switches. So if there's any information that goes around our switch, or maybe just from one device to another within that switch, it doesn't have to go to the rest of the network. So for example, if you have one PC and he's trying to go out to the gateway, he has to go through 3 different switches to get out. However, if there's a server that's plugged into the switch that's on the same switch as his PC is plugged into, it just has to go to that one device and back. It never has to put that kind of emphasis on the rest of our network. Therefore, the amount of traffic passing through our network is less, which means it's a more faster, more speedier network. Okay. So let's apply these concepts now to our rest of our network. Now, I mentioned we've got 24 ports with PoE power. We've got phones going into it. Again, phones are quite small, so it's not really a problem. We can add a couple of access points now because we want Wi-Fi around the network. Maybe we want to think about guest networks and things like that. Now, this is the problem. If we're stuck with unmanaged switches at this point, you've got PCs, servers, everything going, phones and wireless as well, and they're all broadcasting at the same time. Everything is in this one big broadcast mesh. If we was to add in another switch, say 8 ports of PoE, and then add some cameras into there for surveillance, so he's keeping an eye on his office when they're out, he's using motion capture and things like that, it becomes a problem because they're all broadcasting, they're all trying to look at the cameras, they're all doing it in this big broadcasting trunk. Now, if these were smart switches or managed switches, what you'd be able to do is you'd be able to say, hey, I want my cameras on one switch, I want that switch to be part of a different VLAN. We want our phones and things on a different group. And we can use that using this thing called Vlan. So let's have a look at what a Vlan actually is. So here's a really basic concept about what a VLAN is. So here I've got 4 VLANs. Now the default VLAN we're going to call default 1, and you can see how the IP addresses work. So our core switch would have a 192.168.1.1 network gateway. Maybe that's where your router would plug into too, so for your internet, and it would all go out. Now you can see the switches I've used are all managed switches. That means they have their own IP interface as well. They work at that layer 3 part. Okay, so for the first VLAN, we've all got communication. That's going to be my management VLAN. If I plug in any new switches or anything like that, that's not going to be used by the team. They're all going to be on their own network. They're not going to be able to be talked to. Okay, so I want VLANs for my services. So I've got an accounts team, I've got printers and servers, and I've got support teams. That's VLANs 10, 20, and 30 respectively. Now, how I can manage and shape my network, I can say I want VLAN 10 to talk to VLAN 20. I can say I want VLAN 30 to talk to VLAN 20. But I don't want VLAN 10 and I don't want VLAN 30 to be able to talk to each other. So it brings in that security concern. So if, for example, you have people come in with very sensitive data, you want to be able to control what they can do and what they can access. So you still want them to be able to do their jobs, of course, but it means you can start breaking things down, managing your network. Now, for example, we might say, well, the accounting team is very important, the support team is very important, but the support teams use phones, and the phones connect to the customer. So it's really important that everybody's phones and things start working. So maybe I would put all my phones on a different VLAN, and I would start thinking about quality of service to make it more important on my network. So any traffic that's going around my network that's like a phone signal would be prioritized. That's what you can do with VLANs. Also, you can start locking things down. So you can say, well, I want this PC that's on VLAN 10 to talk to this server, but I want the other PC that's on VLAN 10 to not talk to this server, because maybe that person doesn't need that information. It's very sensitive. That's what you can do with VLANs and a managed network.
Good for GDPR, good for data security. There's a lot of uses there, isn't there? That's a very practical for businesses now.
Absolutely. And here's the thing, if you're doing data transactions, especially with customers, and you're using PDQ terminals and things like that, you'll have this compliance checks, and they'll actually try and scan and penetrate your network to see what kind of weaknesses you have. Now, if you use VLANs and things like that, there's a good chance that you can just put your things onto your currently existing network, and it's all secured, and you won't need any extra investment and things.
Planning.
So, yeah, planning. So let's time skip now 6 years into the future. He's growing his company at a vast rate. Let's see what happens.
Whoosh. God, those 6 years went quick, Craig.
Did. So obviously we still need our internet. Our gateway at this point is definitely a business grade network. It has to be business grade. It has to be VLANs, and it also has to be 802.1q, which means it can understand VLAN tags. Now, if you use an unmanaged device on a VLAN-based network, there's potential for disruption, unless you put it right on the edge where it's not going to get disrupted.
That's what I was going to say.
Yeah,
I remember you saying that.
because if you start, so for example, if you've got a VLAN, everything needs to understand VLANs in order for it to work. So basically what happens is, and the number is assigned to a packet, it passes around the network. Every time it gets to a node like a switch, it looks at that, thinks about where it has to go, pulls the number off, puts it back on, sends it on its way. So if you put an unmanaged switch into that environment, you're going to cause problems, because you start doing VLANs, it's not going to understand the tag, it will drop the packet. So our gateway at this point really has to be important that it understands VLANs. So I'm going to connect that to our switch. Our switch will definitely be managed at this point. So let's say, for example, it's a gigabit switch and it's non-PoE, and it has a possible fiber connections going to it.
Most of the core switches wouldn't have PoE, would they, Craig? Because there's no need for it, because they're just the they're just the opening to the network, aren't they? So
correct. You can get them. Yeah, you can get. We certainly sell them ourselves, but generally what you would be best doing is getting another, let's say it's in the same cabinet even, you probably just would get another switch that does your PoE and plug that into the core switch. Core switches generally are fiber switches, and they wouldn't need PoE.
Yeah,
correct. So you notice now that I've gone away from the blue standard Ethernet cables and I've put some red ones in.
Ooh.
Now red generally means fiber in my diagrams. So we're actually going to be connecting these up via fiber. So let's say, for example, the office has grown. It's a big office, it's multi-floor at this point, and what we need to do is make sure that we can get the data flowing between these networks correctly. Now, fiber connections can generally have similar speeds to an Ethernet connection at that lower level. However, the transmission type isn't going to be as good. So even if it's a 1 gig connection, a 1 gig fiber connection generally is better in terms of not so much speed, but the way it sends data than an Ethernet connection would be. So we do prefer fiber, and it goes longer distances as well. So for example, if you're in different blocks, maybe there's different buildings and you have to run some fiber cabling, you definitely want to go with fiber, and then basically you'll have transceivers as well, which we'll go into. So fiber. We've fibered up our core switch, and that will obviously need at least 3 fiber connections coming out for that. Now, what have I done here?
Your
See what I've
favorite.
done? That's going to be our second switch at our core level. Now, this is an interesting one. Why have I done a second switch at a core level? What I want to think about in the future is a thing called redundancy. It's something that we heavily recommend at D-Link. It's something that we deal with the technology on our switches. Redundancy basically means if one device goes down or one route to that device goes down, we've got another route to get there, so our information and our traffic doesn't stop. So in order for me to explain how this is going to work, I'm going to need to start building the rest of my network. Now, fiber is very different, like I said, to Ethernet, and it comes in different speeds. There's 2 types. There's single mode and there's multi-mode. Now, of the multi-mode, there are 4 different types, and of the single mode, there are 2 different types. Single mode is generally a lot more expensive, but it goes much further in distance. So you can do many different types of speeds on single mode. Generally with multi-mode, it's going to be dependent on the type that you use, the distance that you're trying to use it as well. So let's say, for example, you use an OM3 cable, you're using a 10 gigabit transceiver into those devices, you're going to be able to run for about 300 meters in that distance. Okay. Now, if it's OM4 quality, you'll be able to run up to 500 meters with that distance. So that's the difference between the standards. If it's OM2, you might be able to get 10 gig speeds at about 88 meters or less. And then OM1 is very short. It's probably only a few meters actually. Now, I mentioned that I've included a switch with at my core level. What I want to do is I want to stack it, and that brings in a new thing that we're going to talk about briefly, and this is how we're going to build the rest of our network. So what we've seen now is we've seen this very standard topology where everything's kind of connecting all at once, and we grow it in a sort of ad hoc way. So we plug in our device, we give that switch an IP address, and we run out of ports, and then we plug in another device, we give that another IP address, and before you know it, we've got these kind of mesh systems where we're trying to plug everything in, we're trying to give everything a device. Now, the problem with that is you want to make a change in your network. Where are you going to make the change? How are you going to make the change? And if it's something that has to go network wide, think about all the work that has to happen for that network for you to make that one simple change. That's not even accounting for if you've made the right change and then you have to start reverting things. It's all going to get very, very messy. So it's not really the system we want to use. Now, stacking is what we call it. Physical stacking is where you introduce fiber cables. We call them DAC cables, direct attach cables. They're very short cables. Now, in our instance, we use 10 gig cables. So what we want to do is we want to connect each switch with a 10 gig cable, and then on the final one, we loop that back to the first one. So here I've got a ring stack. Now, what you'll notice about this, Alan, right, is that you're able to take one of these switches out, and it won't affect any other switch. Okay, so if one of them breaks, if the PSU goes, if something goes wrong, if it gets zapped by lightning, whatever, starts malfunctioning, it won't affect the rest of your network in that way. We can rip it out. Now, what's also important is this stack has one IP address. It's manageable via that one IP for all of the ports that are on this device. So you don't need to worry about multiple IP addresses. It's all in one system, one block. Now, if you're a small company, if you're a small business, you might be able to put in a stack of switches like this. You'll have one IP address to manage for your entire network with redundancy. If anything goes down as well, you'll be able to chop and change ports, change all the VLANs, make everything segmented, and off you go. If you're a big company, you want multiple stacks. Yeah. So we've introduced the concept of device breaking down. Now, if we link these devices and these stacks together with a fiber cable, what we can do is we can start pushing information between the stacks. However, if one of those fiber cables goes down, we've lost communication going to that stack. So there's multiple things that we can do on our switches to try and alleviate that. One of the things we do is called LACP, or spanning tree protocol. And there's two ways of doing it. Now, if I introduce secondary cables, now anybody who's played with switches in the past and has tried to make a loop knows it throws a tantrum and it starts shutting down the rest of the network. However, if you apply a certain technology and you do it in the right way, what you're able to do is not break the network but improve it. Now, what we've done here is I've done two different cables, one going from the first switch, one going from the sixth switch in that first stack, going to our second stack. Let's say that's, for example, every one of those red cables is 10 gig. I've now got a 20 gig connection going from stack to stack. It's constantly up all the time. If one of them breaks, I still have a 10 gig stack that I can use. If one of those devices goes down, it doesn't break the rest of my stack because it can go another way. So, for example, if the third switch in the first stack breaks, I've still got all those ways of getting to that second stack, and all that technology doesn't kill the rest of my network. Yeah. And that's really what we probably do very well, I would say, at D-Link, is that we can start planning those kinds of networks. So let's start building. So I've now got my core, I've got my distribution switches, which are all fibered up. And let's say that's, for example, that's a 10 gig connection, fiber cable going back to our core network. And then we have our edge devices. And our edge devices, they might just be 1 gig connections that are going to each device.
Yeah.
I obviously start plugging things in. So I've got all of my PCs going into a switch, all of my phones, all of my cameras that are going into that switch as well. So I have to think about PoE, I have to think about how it's going to be connected, I have to think about throughput, I have to think about a lot of different things at this point. Access points as well. I want to make sure I've got lots of good access points in the area. So I'm going to plug that into a device that might be doing PoE or non-PoE. Completely up to you how you do it, but you do need to think about those PoE requirements as well on the network. I've obviously got my servers. Now, what you'll see here now, I've got stacked core, and I also have a stacked distribution. The edge switches, they still got a single connection going into the things. But what you can start doing is, if it's a managed switch, you can start doing things called link aggregation. That's where you start putting multiple cables into multiple switches. Now, with spanning tree protocol, it won't break. It'll just be like a backup connection going to the device. Or if you, like I said, if you use link aggregation, you can actually improve the throughput through each and every device. You just have to account for how many ports that you're doing, how many devices you want, and how much it's more important to you. Whether you want to spend that on transceivers to plug those extra fiber cable connections, it's all going quite well at this point. So the core is still my core. I want to plug all my servers and devices into my core network, but I still want to start thinking about VLAN, splitting them off in certain ways so that my network can still be managed. All my phones are still prioritized. Then I add extra cables now, so it might have been hard to see on that, but I've added cables between the edge switches.
Yeah.
So now I have a loop going on my edge switches. That means if any one of those devices goes down, I'm still able to think about how it can connect through different ways. So if a fiber cable or an Ethernet cable has any kind of problems on it, it doesn't affect the network, it can still carry on. It'll at least give you time to think about how you can improve it or diagnose the problems. Now I've added some cameras, so I want to think about storage as well. Now on a big network, you don't really want to put the storage in the core, because all that means is that you're going to be constantly sending information to the core. You want to offload that as much as possible. So if you offload the NVRs to the same switch as the cameras are connecting, that information, to store that information, is based on that switch and that switch alone. It's not going to go to any others. But what that does mean is that you can plug a PC in the core and you can get full coverage. So it can see group 1, group 2, and group 3 in this example, I could be able to see all the footage from one single view at that core area, but I don't have to worry about storage or sending that information through my network. And then finally, because we've got our gateway involved, we can do VPNs, and we can start doing VPN services so people can VPN into the network. They can start working from home. They can start doing all of the functionality and still get to all of the devices, all of the servers, and work from home like you are pretty much doing today.
Very important.
Yeah, and we're doing that through maybe our leased line or our 4G connections. There's lots of different things we can do. But that's basically the building blocks of a network, from very simple to quite advanced, with a few technologies in there that might interest you if you ever get a project like that, or if you're looking for something that might be very similar. Think about that kind of technology where you can implement speeds, where you can think about PoE power, where you think about the amount of growth that you're going to go through, how you're going to offload it in a way that makes sense as a network.
Yeah, it's there's a lot of planning that needs to go in, isn't there, Craig? It's number of ports per person that's necessary, what exactly people are going to connect, the phones, the cameras. As your business grows, you need more security, more people. Yeah, there's so much to consider, and it can really aid your company to have a network where you've actually thought about this kind of stuff, rather than being reactive and having more people join and then realizing that you don't have any room on the network, or you don't have a separate space to set up a Vlan so that you can keep your financial information away from your HR information and do those kind of things that will hinder your business's growth in the future. It's there's a lot to consider. And I think that's why it's good that you're here, yourself, Craig, and always available to answer all of our lovely customers' questions.
Absolutely. Well, what I do generally advise is, if you are thinking about growth like that, then maybe look at a stack switch. Even if you're not going to stack it today, you might be able to stack it later on, and you just add switches to your stack as and when you need them. So that's another benefit of thinking about the series and future-proofing it in that way.
Yeah, I think a lot of people will look at the price and the price difference, and they'll consider what it is today versus what their actual needs are tomorrow, and they'll think, I can save a little bit of money here. But I think the message from us is just weigh that current saving up against future expense, because if you buy that switch and that switch is no longer usable in your network because you've got tons of unmanaged switches, but now you've got to set up VLANs, you've given yourself a little bit of unnecessary expense there. So
yes, absolutely. Yeah.
Okay. Well, thanks a lot for that, Craig. I learned a lot, so I hope everybody else on the webinar did. It was very, very useful. As I've said, yeah. Craig is available. We did the Wi-Fi planning tool a couple of weeks ago on a webinar, which is sort of related to this one, but it's just another place where D-Link can help you out with all of your needs, your network planning, and all that kind of stuff. But if you do have any questions, if you do have any queries, the telephone number's up on the screen now, or you can drop us a line at UKI-sales@dlink.com. Craig is available to guest speak at all parties and family gathering, or just if you need help with your network, whichever way you choose.
Yes, if you want to, what you can do is just drop me an email if you want to include any kind of network designs that you've currently got, or just ideas that you're thinking of, and you just want to kind of sanity check anything, just send it my way. UK&I Sales is the best way to get in touch. And then you'll be able to have a look and maybe give you a call. So feel free to ring us too.
Yeah, I think it's just important to show the evaluation at every stage, to look at the switches. Do you need to have managed? Can you save money with a smart managed, or is there going to be a need for a managed switch in the future? And I think that's what we've been through in the presentation here today, and what Craig can really help anyone out there who's got an ongoing project to look at. And maybe the saving or maybe spending the extra might be the part that wins you that all important contract. So don't hesitate to get in touch. We'll be back doing another webinar as usual in 2 weeks' time. It's going to be going into VLANs in a little bit more depth. So that might be good for Craig, because he's already done some of the slides here today, but we're just going to dive a little bit more into depth on those. So I hope to see you again in 2 weeks.
So it's particularly going to be of interest if you already have any D-Link switches, perhaps. There are some features there that might not have seen before, so I'll probably throw in a couple of extra technologies as well, so that you can get the best out of those VLANs too.
Fantastic, and good for me, because it's more work for Craig and less work for me. So always good from my end. Just to say thanks to everyone for joining. We'll see you again in a couple of weeks.